Hey everyone, today we are going to solve system of equations and we are going to focus on the graphing and the substitution method. So first off, let's just go over the classification of linear systems. We have consistent and independent. That occurs when we have one solution. Okay, so you can see here that we have intersecting lines and there's only one solution. That's right where they intersect. If you have a line on top of another line, that would mean infinitely many solutions, and we would classify that as consistent and dependent. And then if we have parallel lines that do not intersect, that would be inconsistent. Okay, so if there's no solution, inconsistent. If there is at least one solution, it's consistent. But if we just have where the lines intersect one time, that will be independent. But if we have a line on top of another line, then that would be dependent. Okay, so I'll refer back to those here in a little bit. But let's go ahead and start solving some of these down here. Let's learn about the graphing method. So in order to graph system of equations, we're going to write each equation in slope-intercept form first. Then we're going to graph each line, and then we're going to write the point of intersection, if there is one, as xy. That's the coordinate point, and that will be the solution of your system. We are then going to talk about how to graph them on the graphing calculator to check. So I'll go over that as we work through a couple problems. So down here it says graph the system and estimate the solution. Then check the solution using your graphing calculator and classify the system. So first step was write each equation in y equals mx plus b form. So if we look right here, this is not in y equals mx plus b form, so we need to do that. So I'm going to rewrite that equation over here. Okay, and I'm going to get it in y equals mx plus b form. So I'm going to subtract 2x from both sides. Whoops. And I get y equals negative 2x plus 5. So that's one equation. Now this guy is not in y equals mx plus b form either. So I'm going to rewrite him and get him in y equals mx plus b form. So I'm going to subtract x from both sides. And I end up with a negative y, because there's a minus sign right there, equals negative x plus 1. Now this y is negative. I have to get rid of that negative by dividing by a negative 1. We need it to be positive. So 2 negatives make a positive. Again, 2 negatives make a positive, and that's just x. X divided by 1 is just x. And then a positive divided by a negative is negative. 1 divided by 1 is 1. Okay? So now that I have my equations in y equals mx plus b form, I'm going to go ahead and graph them. So my y-intercept here is 5. 5. And my slope is negative 2, 1. So down 2, right 1. Down 2, right 1. Down 2, right 1. And I'm going to go ahead and connect those. And use a roller to have nice, pretty straight lines. Okay, and since it's an equal sign, it's just a solid straight line. Okay, and then my y-intercept on this equation is negative 1. My slope is 1, so I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, and so forth. And I'm going to connect those dots. Okay. So after I've graphed each line, I'm going to write the point of intersection. So my point, or my graphs intersect at this coordinate point right here, which is 2, 1. That would be my solution. And to classify it, let's look back up at the top. One solution, intersecting lines with one solution, was called consistent and independent. So I would say consistent and independent. Okay, so that's just vocab right there. Now let's go ahead and check our solution on the graphing calculator. I'm going to read the directions up above so you can follow along here. But it says go to your y equals screen. You need to clear anything out right there. Equation 1 is going to be negative 2x plus 5. And equation 2 is x minus 1. Okay, then it says click graph. So I'm going to hit graph. Now I have a bunch of little lines right here. If you guys hit zoom 6, that will take you back to a 10 by 10 window. Okay, and I can see that I have an intersection point right there. So if you hit second, it says trace, and it says to go down to number 5, intersect. And then the last step says move your cursor to the intersection and click enter 3 times. So here's my intersection. I hit enter, that's 1, 2, 3. And your calculator screen should read intersection with an X and a Y equals. And look, 2, 1, which is what we have. So yay, we're awesome. Okay? All right, let's try another one. So down here, these are not in y equals mx plus b form, so I need to get them there. So I got 2x minus 3y equals 12. And I have x plus 2y equals 4. So let's go ahead and get these in y equals mx plus b form. So I'm going to subtract 2x first for this equation, and I get negative 3y equals negative 2x plus 12 minus 2x, positive 12. Then I'm going to divide everything by negative 3 to get rid of that. So I get y equals 2 negatives make a positive, so 2/3. X, positive divided by negative is a negative. 12 divided by 3 is 4. Remember, you can use your calculator if you're unsure about any of this division right here. Okay, let's go ahead and graph this guy. So we get negative 4, 1, 2, 3, 4. My slope is 2/3, so I'm going to go up 2, right 3. Up 2, right 3. Draw a line. Okay. Oh, oops, sorry guys. All right, let me get my second equation here. So I'm going to subtract x from both sides because I need the y by itself. So I get 2y equals negative x plus 4. And then now I'm going to divide everything by 2 because I got to get y by itself. So y equals negative 1/2 x plus 2. 4 divided by 2 is 2, right? Remember, there's a 1 right here. This is negative 1/2 because there's a 1 in front of that x, okay? All right, so let's graph him. His y-intercept is 2. My slope is down 1, right 2, down 1, right 2, down 1, right 2. Okay. Now these graphs, it intersects at one point, right? It's kind of hard to tell what that point might be. So let's use our calculator right now to try to get a better idea. But it looks like it's going to be 1, 2, 3, 4, 5 point something. And then if this is negative 1, it's going to be like negative 0.6 maybe. But let's check that in our calculator, okay? We do know it is going to be consistent and independent because I have one solution from the classification. Consistent and independent. Okay, here we go. So let's go back to our y equals screen. If you guys hit, I can put it right there, hit clear. Scroll down in here, clear again. So I've got, to type in the fraction, remember you hit alpha, y equals in number 1. So we got y is 2/3 x minus 4. And we get negative alpha y equals 1/2 x plus 2. Okay, hit graph. Okay, we see our intersection right there. So remember, we hit second, trace, and we go down to number 5. And your notes say to move your cursor towards the intersection. So you're just using the left and right arrows to do that on your calculator. And hit enter 3 times. 1, 2, 3. My intersection has an x and a y value. The x value was 5.14. And my y value is negative 0.57. And that would be my solution. Okay, So you can use your calculator if it's not like exactly on a point right there to double check it. Alrighty, let's do one more. Letter C. Man, these aren't in y equals mx plus b form either. Making you guys do a lot of math. That's okay, that's a good thing. Right, we gotta practice this. Okay, so let's rewrite this first one in y equals mx plus b form. So let's subtract 3x from both sides. So 2y equals negative 3x plus 12. And then I'm going to divide everything by 2 to get y by itself. So y equals negative 3 over 2x plus 6. And then over here, I'm going to subtract x from both sides. And I'm going to get y equals negative x plus 3. Okay, so I got rid of that. Okay, so let's go ahead and plot these. So my y-intercept on this equation is 6. 1, 2, 3, 4, 5, 6. Oh, barely made it. My slope is down 3. 1, 2, 3, right 2. Good. Okay, let me connect my dots real quick. Okay. And then this one was, the y-intercept was 3. And remember that slope, that's just a negative 1 right there. So that could be negative 1 over 1 if you want to think about it like that. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Oh. I was getting nervous there if these were going to intersect or not. Oh, whoops. Okay. This one's a little harder to tell, but you guys can see that it intersects right there. Okay, so that is at 1, 2, 3, 4, 5, 6. 1, 2, 3, negative 3. Okay. And again, that's just one intersection, so that would be consistent. Oops. And independent. Oh, my pen's running out. Okay, so let's check it on our calculator. So go to the y equals screen. Let's clear these ones out. I got negative alpha y equals, so type in the fraction, x plus 6. And then I've got negative x plus 3. Now remember, when you guys are using the negative sign, it's this little button down here when you have a negative. Okay, don't use the minus sign for these guys right there. Okay, those should be the negative button, which is down here. So let's hit graph. Oh, did I type that in right? Oh, okay, oh, sorry. Yeah, we're good. Okay, so second trace, we want the intersect tool. Move your cursor to where you think they intersect. That's using the left and right arrows, remember. 1, 2, 3. Intersection at 6, negative 3. So we're awesome. Okay, now remember, if you have parallel lines, that is an example of no solution, and that would mean that they're inconsistent. An example of what would happen if we have infinitely many solutions, if that would happen if the lines were the same. So that means that both of the equations are the same. Okay, so this would be the same line. Parallel lines mean that you have the same slope. Okay, so there's just an idea of what those might look like. Okay, so that's how we graph. That's the graphing method. Let your teacher know if you have any questions.